So let's test out our knowledge of this with a quiz. We're going to go back to our JavaScript interpreter and add support for looking up variables like x and y. The first change is that our recursive evaluate expression procedure now takes two arguments, the abstract syntax tree and the environment, because we've just established that the meaning of an expression depends on the context in the world, depends on the environment. We've already seen these two cases before. We peel apart our abstract syntax tree, which is just a bunch of nested tuples. We look in the 0th component for the type. If it's a number node, then we just return the string value converted to an integer. If it's a binary operator like plus or minus, we'll have to do the addition or subtraction. Here I'm skipping a few steps compared to last time. Last time we assigned tree1 to left child and then called eval.exp on it. I'm going to do it all in one line now just to save a little space. But notice that when I make my recursive calls to add to eval.exp, I have to pass in this environment in order to have my subchildren, the subparts of the AST, know what the values of variables are. And since there haven't been any intervening assignment statements, the environment stays the same. Whatever I was given is whatever I will pass on to my subtrees. So now I just check to see. If the operator is a JavaScript plus, I evaluate it using Python plus. If the operator is JavaScript minus, I evaluate it using Python minus. I translate these basic universal concepts like addition and subtraction from one language to another. I'm writing an interpreter. But what if, instead of being a number or a binary operator, our node type is identifier, is actually a reference to a variable? And just to remind you, here I've written out our abstract syntax tree for x plus 2. At the highest level, it's a binary operator, where the left child is the identifier x and the right child is the number 2. So we started up here with binop, but that involves calling ourselves recursively to evaluate our left child. When we do, the node type for our left child is identifier, so we're going to have to figure out what the value of x is. So your mission is to complete the code for this case by finding the identifier name, looking it up in the environment, and returning it.